Hello, geometry students. This is Jami. My name is Jami, and this video is our discussion on sections 5.5 and 5.6. 5.5 first, title is Indirect Proofs and Inequalities in one triangle. In indirect reasoning, all possibilities are considered, and then all but one are proved false. So that remaining possibility has to be true. A proof involving indirect reasoning is called an indirect proof. Okay, so here are the steps on how to write an indirect proof. First, you identify the statement that you are trying to prove. True. Okay? After that, you're going to write the negation of that statement. So let's say you're trying to prove that x equals 5. So that's step one, identify what you're trying to prove. Then you would write the negation, x does not equal 5. Then you would have to show that your negation is false. Okay, if the negation is false, then the statement we are trying to prove has to be true. Okay, remember that is because negations have opposite truth values. So let me just talk about the possible outcomes. If this one you can prove false, then this one would have to be true. The only other case scenario when you're talking negations would be if this one ends up being true, then this one is false. It has to be one or the other. A statement and its negation have opposite truth values. So our goal is to figure out what we're trying to prove true, and then the strategy is to take the negation and prove it false. And what that would in turn mean is that this one that you were trying to prove true is true. Hope that makes a little bit of sense. Let's try one. Okay, write an indirect proof that a triangle cannot have two right angles. Okay, a triangle cannot have two right angles, it's a true statement. A triangle can't have two right angles. If I do one right angle and then my second one, if I do a right angle, the figure won't close. So get 90 degrees plus 90 degrees, that's already all 180 degrees. So we know that if a triangle cannot have two right angles. So we just need to prove it now. Okay, so step one, identify what we are trying to prove. A triangle cannot have two right angles. Step two, we're going to write the negation. That would be a triangle can have two right angles. Okay, so now our goal is to prove this negation false. That's our challenge, okay? We have to prove a triangle can have two right angles. We have to prove that false. All right, we're going to prove it false. Here we go. We're going to use the triangle angle sum theorem. Remember, the triangle angle sum theorem says that all three interior angles of a triangle have to add up to 180 degrees. So we're going to use that theorem. Measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180. I guess I could have left our figure here. 1, 2, 3. 180 degrees they have to sum up to. Okay, so now what we're going to do is turn the measure of angle 1 into 90 degrees and turn the measure of angle 2 into 90 degrees. Okay. All right, combining like terms, that means 180 degrees plus the measure of angle 3 equals 180 degrees. Okay. Subtract 180 from both sides of the equal sign, and that gets us a result of the measure of angle 3 equals 0 degrees. Okay, that statement right there, let me erase some of this. This is the key, because we have now written a false statement. This was fine. This starts to get questionable depending on what this is. Questionable depending what this is. But when we narrow that down to the measure of angle 3 equals 0 degrees, that is wrong. We cannot write that statement. because angles cannot measure 0 degrees. So a triangle cannot have an angle with the measure of 0 degrees. Therefore, a triangle cannot have two right angles. So we proved this one false, and therefore its negation, our original statement that we were trying to prove true, is in fact, well, is now proven true through an indirect proof. Okay, the triangle inequality theorem says that if two sides of a triangle are not congruent, okay, so if they're not the same measure, one has to be longer and one has to be shorter if you're comparing them to, because they're not the same, then the opposite angle of the longer side is greater than the opposite angle of the shorter side. All right, let's try to look at this picture and figure this out. So if this angle right here, angle Y, let's say that that one is an obtuse angle, okay? It looks like it's maybe just over 90 degrees. So if this angle opens just over 90 degrees, then to connect these endpoints, we'd have a longer side. Now let's switch colors. This one here is the smaller angle. That's an acute angle. So if you open the angle up this much, this connection piece right here would be shorter than that of the side opposite Y. Okay, let me erase that stuff there. So if side XZ is greater than side XY, then the measure of angle Y will be greater than the measure of angle Z. The converse of the triangle inequality theorem is also true, okay? So that would be, you can go this direction. You can change this right here to the if statement. If the measure of angle Y is greater than the measure of angle Z, then this side is longer than this side. All right, a corollary to that is that the measure of an exterior angle of a triangle is greater than the measure of either of its remote interior angles. This one makes sense if you think about that theorem that says the measure of this angle is equal to the measure of this angle plus the measure of this angle. So if it's equal to the sum of these two angles and neither of these can be 0, then angle 1 would have to have the greatest measure. So you can see here, if angle 1 is an exterior angle, then its measure is greater than angle 2 and it's greater than angle 3. That's the corollary to the triangle exterior angle theorem. Okay, so we have a triangle here, and we can see the lengths of the sides. We've got the longest side, 175. Valley Road is the medium side, if you will, and then MLK Boulevard is the shortest side. And it looks like that's a park in there. So a town park is triangular. A landscape architect wants to place a bench at the corner with the largest angle. Which two streets form the corner with the largest angle? Okay, so this is a pretty reasonable question. Let's say you're the architect and you have one bench, so you want to put it at the corner that has the greatest measure. Well, he knows that this is the greatest side, therefore this would be the greatest angle. So Hollingsworth Road is the longest side, so it is opposite the largest angle. So it is MLK Boulevard and Valley Road that form the largest angle right here. MLK Boulevard and Valley Road. Okay, side lengths versus angle measures. So let's list the sides of this triangle from shortest to longest, okay? Shortest to longest. Well, we need one more angle. We need that other measure. So what is 180 minus the 58, and minus the 62? Let me do this on my calculator real quick. 180 minus 58 minus 62 is 60 degrees. Okay, so we know this one is 60 degrees. So if we put the angles in order, shortest to largest, let me erase some of this. Put the angles in order, shortest to largest, it would go maybe small, medium, large. We can write it like that. So the sides would be, this is the shortest side, medium length side, longest side. So we have measure of angle T equals 60 degrees. So we have our smallest angle being U, then T, then V, which makes our side lengths. TV would be the smallest, UV would be the middle one, and UT would be the longest. And there they are, listed in order from shortest to longest. The triangle inequality theorem for sum of lengths of sides. Okay, says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so you can't have one side of the triangle, a triangle that's longer than the other two sides combined. I mean, it kind of makes sense. Think about that. Let's say you want this to be one side of your triangle. Well, you can't have this and this be the other two sides because there's no way to form a triangle out of those three segments. So the red side plus the blue side has to be greater than the black side. It's also true that the blue side, and I mean the measure of it, of course, the measure of the blue side plus the measure of the black side has to be greater than the red side. And the third one, the measure of the black side plus the measure of the red side has to be greater than the measure of the blue side. All right, so let's use that fact to check out if a triangle can have sides with the given lengths. So we've got 3, 7, and 8. All right, none of those seem unreasonably long, but let's just check real quick. 3 plus 7 is greater than 8. 7 plus 8 is greater than 3. And 8 plus 3 is greater than 7. So we're good there. That's fine. Let's try part B. 5, 10, and 15. Ooh, this one is a little concerning. 5 and 10. 10, let's say this is 5. Let's say this is 10. 15, it's not greater. So you can't form, it's equal to, but it's not greater. You can't form a triangle out of those three segment lengths. So we just have to state that 5 plus 10 is not greater than 15. And so no, the sum of 5 and 10 is not greater than 15, and you cannot have a triangle with those given lengths. Finding the possible side lengths can be done using that theorem as well. Two sides of a triangle are 5 feet and 8 feet long, let's say. What is the range of possible lengths for the third side? Okay, to find the range, let's call X the third side, okay? So we've got a side that's 5, a side that's 8, and we want to know the range X could be. It's real simple to do. You just do the difference of the two, so minus 5, minus 5. So there's the difference of the two sides is 3. And then you do minus 8, minus 8. And this right here is negative 3. And then you do their sum. 5 plus 8 is the sum. So we have 3, negative 3, and 13. Well, X, the third side must be greater than 3 feet and less than 13 feet. This one, X cannot be a negative value because it's a side length. So we're just using these two here, 1 and 2, which basically ended up being, you just take the 5 and the 8, you guys, do their difference and do their sum, okay? And you're good. Okay, section 5.6, title is Inequalities in Two Triangles. And we're going to start with the hinge theorem. I like to think of this one as like the hinge on your door. So if you walked up to a door right now and pretend this is the hinge, okay? So this is if the door is closed, and then what you do is open the door to some angle, okay? Some amount. So now the door is over here. So this amount that you open the door is going to produce this side length right here, the red one. Let's check this door out. So let's say your door is closed, it's like this, and you open the door. So now the door is here. So you opened it this angle, this amount in blue. It's going to produce this side length, which is going to be smaller. Okay, so if you open this door more, giving you a bigger angle, let me erase some of this. If you open the first door more with a bigger angle, you're going to get a bigger side. If you open the door less, you're going to get a smaller side. And that's basically, that's my way of oversimplifying the Hinge theorem. It's that if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite the larger included angle. So there it is in the more formal writing. And so you can see here, if your measure of angle A is greater than your measure of angle E in this figure, then your segment BC will be greater than the measure of your segment FG. The converse of the Hinge theorem is also true. So look out for that. We could make this the if. So if that red side is larger than the measure of the blue side, then it's fine to conclude that the measure of angle A is greater than the measure of angle E. All right, so let's use the Hinge theorem. So you're going to fill in the blank there with an inequality. So it's either a greater than symbol or a less than symbol. Go ahead and pause the video and try it now. Welcome back. If you came up with greater than, you got it right. And SK is right here. It is opposite of a 90-degree angle. YU is right here. It is opposite of a, Y to U is right there. It is opposite of a 70-degree angle. So since SK is opposite a larger angle, it's a larger side. So SK is greater than YU, and the solution is because angle A is greater than angle O. Justification, Hinge theorem. The converse of the Hinge theorem now. Okay, what is the range of possible values of x for this figure? Okay, so there's our x, and we want to figure out the possible range for that value right there, that x. Okay, well, it's an angle. We know that. And we know that an angle has to be greater than 0, right? So we know that that 5x minus 20 has to be greater than 0 degrees. So that's nice. That's giving us a range. Oh, I also see that the 60 is opposite of 15, whereas our angle is opposite a 10. So this angle that we're interested in has to be smaller than 60 degrees. Do you see that? The 60 is opposite 15 and ours is opposite 10. So that means our angle, the 5x minus 20, has to be less than 60 degrees. So we just found the range. Well, not quite, we're not quite done, but the 5x minus 20 has to be greater than 0, and the 5x minus 20 has to be less than 60. Well, it's a fancy 6 there. Okay, so it has to be between 0 and 60. So our algebraic expression, I'm going to write this out different. Our algebraic expression, 5x minus 20, has to be between, like that, 5x minus 20 has to be between 0 and 60. Okay, so we would solve for x. It's the 3 parts to your inequality, so add 20 to all 3 parts. Less than 5x less than 80. And then divide all 3 parts by 5. So that's 4 is less than x is less than 80 divided by 5 is 16. And there we go. We have our range of x. It's got to be between 4 and 16. And it can't be 4 because that would make the angle 0. And it can't be 16 because that would make the angle 60. So it's got to be between the two, which is why we don't have the less than or equal to symbol there. So here's another just way to write the steps out, focusing on the upper limit first, which is 60, and then focusing on the lower limit, which is the 0. So instead of just doing it in one inequality, it's done there in 2. Same result, x has to be greater than 4 and less than 16. And that will conclude our discussion on Chapter 5. My name is Jamie Emigh. Thank you so much for joining me, and I will see you next time for our discussion on Chapter 6.